Hello Gators, this is 1.2 Functions and Graphs. We're going to be looking at domain, range, notation for it, graphs, odd and even, and piecewise and composite functions. Let's take a look at what a function is. Remember, it's a rule that assigns every element in the domain a unique element in the range. I've given you kind of an input for domain, output is range. Take a look at what is a function and what is not a function. A good rule of thumb is for a function will pass the vertical line test. This assures us that every x will have one y. Remember that domain are the x values, the range are the y values. Take a minute to stop the screencast and see if you can answer all of these questions. And here are the answers. Number 1, yes, it's a line. It passes the vertical line test. Number 2, circles, no. This particular one has an x value where there are two y values. Number 3 is a parabola that's going down, and that will pass. Number 4 is not. It's not a function. It's a parabola, but it's a sideways parabola. Very similar to a circle, will violate the rule. Number 5 is a function notation. You're putting 10 into the function f. Number 6, we're putting something a little bit more complicated into g, and then we actually square it. Number 7, this is called a composite function. We'll talk more, but the f of x function, which is 3x minus 1, is being put into the square function. Number 8, another way to write this is f of g of x. G of x, the squaring function, is being put into the linear function. Let's determine the domain and range for each function, and stop the screencast and see what you can do. And here are the answers. Number 9, I graphed it for you. This is the root function. It's being translated over 1 unit. A lot of times it's a good idea to draw a t-chart. And our domain looks like this. I'm very accepting of this as the domain. If you like interval notation, certainly you can use interval notation, and the domain would be written like brackets 1 to infinity, and the range would be written as 0 to infinity. Over here in number 11, this is the reciprocal function that's been translated over 2 units. If you like interval notation, it will be negative infinity to 2 and 2 to infinity. And if you like interval notation for the range, negative infinity, and it does not include 0, and 0 to infinity. You can see for number 11, we have some y values that are not being used from 0 to 1. So we have to say y is less than 0, y is greater or equal to 1. Let's take a look at even and odd functions. An even function is such that if you have a point and you substitute the opposite value for x, the y does not change. The graphical characteristic is the symmetry with respect to the y-axis. An odd function is if you have a point and you substitute the opposite value of x, the opposite of value of y comes out. And that's symmetry with respect to the origin. Let's see if we can recognize even and odd functions. Well, I hope you recognize that this one is even. We just looked at it a few minutes ago. This is the x squared that's been shifted up. It still maintains its even status. It will still have there'll still be symmetry with respect to the y-axis. F of x is equal to x. That is our line right here. Sometimes students feel more comfortable if I give them a point. Like say this is the point 3, 3, because if you put 3 in here, you get 3 out. And if we change the sign of 3, if you put a negative 3 in here, you're going to get a negative 3 out. And that's an example of symmetry with respect to the origin. You can see when you change the sign of the input, it changes the sign of the output. Now let's take a look at the other line. The other line is a translation, so it looks something like this. Let's see what happens here. If I put the point 3 in here again, 3 now becomes 4. Let's go ahead and change the x value to negative 3. If I put f of negative 3 in here, I am going to get negative 2 out. And you see this is not what an odd function is supposed to do. And so because this is not happening, Although we recognize this was odd, this is neither. It's neither even nor is it odd. Let's take a look at graphing piecewise defined functions. These are the restrictions on the domain, and I put them in color to help you. When I help my Algebra 2 students, I always told them to make little t-charts, x and y, and we're going to use 0, and we're going to use a point that's before 0, like say -1. And so this is 0, and then this will be +1. So we're going to put an open circle here, and then -1, 1, and then we're going to have our ray here. Now for the second function, and its restriction is from 0 to 1, so I do want to use 0 and I do want to use 1. My answers are both 0, and then this one is 1. So when I graph 0, 0, because this is the equal part, I have to fill in the circle, and then 1, 1, and remember that is equal, so I know I want to fill in circle, and then I just complete the line. On the last part of the domain rule, I want to use 1 and a number greater than 1, and all outputs are 1. So I have a open circle, but since it's already filled in, I'll just write it that way, and then 2, 1, and then it just continues as being a constant, and there we go. And that's how we graph it. Okay, let's do it again. Again, the restriction is before 1 and after 1. And some people like to draw a little dotted line here so that it reminds them they're looking at one side and then the other side. So I'm going to write x and y, and I'm going to use the number 1, and I'm going to use numbers before 1, like 0, -1. So 1, 1, 0, and 1. And let's go ahead and graph that. So it's an open circle here because I have the less than. So open circle, 0, 0, and -1, 1. And it's this V look. And it's not a complete V look because of the restriction on the domain. Now to graph the other one, I know this is just a line. Let's go ahead and graph that line. I'm going to use 1 and a number bigger than 1. 1 will be 3. This will be 4. So this is 1, 3, closed circle. 2, 4, and I'm going to draw my line. So this is the piecewise function, and you see they aren't connecting there at 1. They want me to give me the domain and range. So the domain here is all real numbers. I got every x is available. The range, it looks like my lowest value is 0, and I climb up to infinity after that. All right, writing a formula for a piecewise function. Suppose I give you a graph and you have to draw it. Now I'm noticing that my restrictions are from 0 to 1 and from 1 to 2. So I have two different rules. And this rule right here looks like the line y equals x. I have a slope of 1 and I pass through the origin. So I'll just write x. Okay, now this one has a different, this is a slope of 1 and it passes through the point 1, 0. So I have 1, 0, and I have a slope of 1. Let me go ahead and write it in point slope form. Y minus 0 is equal to 1 times x minus 1. And when I can not worry about the 0, and so this will be x minus 1. So this is the rule I want to use for this line, so I'll write x minus 1. You can check your work, put a 1 right into here, see that if it graphs a point, put the number 2 into here, see if it graphs a point. There we go. All right, absolute value function is one of the most famous piecewise functions, and so when we write absolute value, this is the way we write it when we're not using the symbol. It's going to be very important that you be able to do that. Graphing adjustments. So these are all the transformations that we taught you in Algebra 2, we taught you in pre-calculus. Number 1, 2, 3, 4, 5, 6, 7, and 8. Yeah, those need to be very comfortable for you so that we can get those graphed quickly. All right, let's go ahead. I'll give you an example of one, but I can give you any of those that I just pre-listed. Now the parent function, I know what the parent function is. The parent function is the absolute value function. And I know the absolute value function looks something like this. Okay, now what is this doing? Well, this is a to the right 2 units and down 1 unit. So that's what this thing is doing. So I'm going to go over 2 units and then go down 1. And so now let me pick a different color here. And so that'll be this. And there we go. And domain will be all real numbers. We can have any x. And my range is going to be from -1 to infinity in interval notation. Composite functions, we were looking at them before. We're setting a function into another function. There's some domain issues, and so let's go ahead and take a look at a situation. Remember that f of g is the same thing as f of g of x. So let's go ahead and function composition is not commutative. Okay, so if you if you reverse the way you put in those functions, they are not the same. So be very careful. Okay, so this says to send 2 into g. So I'm going to send 2 into g, and when I send 2 into g, I am going to get a 4 out. And this says send the 4 into the f of x function, and that'll be -3. And so that's how you can evaluate. A lot of us do this in our head. Okay, let's go ahead and take a minute to stop the screencast, see if you can figure out all these values, including the domains of those composite functions. And here are the answers. Let's go down to the bottom here. F of g of x, g has a restriction. And when g has a restriction, it's going to be noted right here in the domain of the composite. Now, for this c thing, f of x has no restrictions, and it's being sent into g. And once it's being sent into g, we do have an issue. We're not allowed to have x equal to -1. So you need to make sure you understand what make those restrictions. And we're done.